Oh my dear goodness, it's been ages since I've streamed. Let's see if this even works still. The YouTubes. Oh, look at that. Flexgate. Wow, that's pretty low latency. Audio? Quick is the easiest way to do an audio test. Perfect. Audio off. Live. Cool. Emails and everything. Cool. Suppose I should get ready while waiting for one or two people to show up. Luce, I should make you a moderator. I should make you a comment moderator. Why not? It just showed I was live and now it's like not there. What the heck? Subscriptions? Yes. How can I watch chat on this? I guess. Audio done. There we go. Welcome to live chat. Remember to guard your privacy. Yes, sir. Okay, looks. Organize some of the stuff. Ooh, put this in view because it's cool. Yeah. Move that. That all there. Got my kits out. Got my flex. Check this flex to make sure it's good. Looks good to me. Alright, I guess I'll show what I'm looking at here. So this flex cable that we put together in our kits, this is the back side of the cable. Quite a few people have asked, how do I remove this material? Yes, that indeed is a complicated part of it. So we remove the back of the flex cable, we prepare the front of the flex cable, and this is what you would get with our kit at least. It was fun having this thermal camera in here now. Happy about that. So, I suppose, let us start. Let's see, to show a little bit more, what is in this kit work desk? So, you have a jig itself. This jig, what it does is it's designed to clip onto the edge of the screen perfectly. Has some internal guts inside of it too that are shaped specifically for the portion of the bezel that is actually indented a little bit where the flex cables go. A couple of wedge pieces. I couldn't figure out a better way that you just put in there to hold it into place. You get a cutting jig that tells you exactly where to cut it, or it lines it up for you to cut it, and then you have a soldering jig that kind of helps hold everything down while you solder it. The idea of this jig is that it helps line up your new flex cable so that it is not very time consuming and it's easy to the point where if you have a little micro soldering experience, especially a micro soldering pencil, that you should be able to do it. I'm gonna set my temperatures now. And that it makes it 4 millimeters longer. That is the length that we decided we liked, and that has been working very well for us. So let's take a quick look under the microscope. What do we have here? This is another shop's attempt at repairing Flexgate. And let's unplug the battery first, because we're going to be poking around a little bit right now. Okay. This failed, obviously. I don't know what kind of a job they did or what they were assuming would happen, but conformal coating is not flexible. Thus, it has peeled up, and when you open this screen, let's see if I can do this in a way that is visible. My microscope all the way to the end. Okay, let's focus this a little bit. Yes, you can see that when you open it, the conformal coating stays there with the wires in it, and the flex cable bends away. And so there's no connection. Terrible way to do it, in my opinion. I honestly did not offer this as a repair. For the first 2 years, Flexgate was a known issue. And the reason was because I did not believe that I had a way I could fix this problem professionally. So we didn't offer it. I did not want mediocre jobs to leave our office and our shop and then come back, and I didn't want to lie to clients, and I also didn't want to charge a client for something that would only work for a month or a week or a day or whatever their luck was. Let's pick this off and see where it really failed. Actually, let's unscrew this and see where it really failed. Where is my T3? T3? This is going to take a lot longer than one of these repairs normally would because we're recording it. I'm explaining every step of the way instead of just doing it. So let's pick and poke here. Huge solder glob. That's interesting. So it looks like this technician, what they did was they just tried to repair the cable. That's not connected. That might be... like... plug that. Unscrew this. We're getting a little bit ahead of ourselves here, but I am quite curious and want to show why this is not a professional solution. What failed in his case? Well, as you noticed, it was soldered on the bend, so I guess I wouldn't be too surprised if it didn't just crack again. This portion looks cracked. Looks like here it might be cracked as well. No, that's not cracked, okay. Just looks like it's cracked right there. Is that even in the camera view? Yeah, alright. So, when... oh! Why, hello there. With that being said, that is one of the problems. If you add material to a flexible joint that is already failing because its bending radius is too small, then you are going to run into more problems with it bending. So let's prepare for this repair. When designing this kit and when thinking about it, I wanted it to be simple. So I've never taken the screen all the way off to do this repair, personally. You do have to remove the antenna. I don't do any modifications to the antenna. That screw did come out, okay. I don't know if we can get away without removing, nope. We do have to remove the, I don't know what you'd call these on the sides of the screen, the plastic hinge screw covers. Remove the rest of these little T2 screws. This motherboard is missing a heatsink screw. Motherboard's missing a couple of things, to be honest. It's missing the fan seals, I guess is what you could call those. Never like it when I see that. The Touch ID is not working. It seems that this board was a replacement board. Unfortunately, there's nothing you can do about restoring that Touch ID unless you are Apple. Stick that there. Wonder how much of this is in the camera. There we go. I'll twist the camera a little bit. There we go. I do like to remove these two. Give me a little bit more flex. 1, 2, almost 2, 2. So it has been ages since I made a video on YouTube. Work has been good. Lots of it, which is always better than no work. Pop this out. You can take it all the way out, or you can just kind of leave it in a little. I guess I've done enough times where I don't have that much of a problem putting it back in. I do remove this. Normally I just like kind of twist it out of the way, and what is that? Oh, that's just what I chipped off a moment ago. Don't want that getting down into the hinge mechanism. While I'm in here, I try to brush this off gently and blow it out. Don't really want any Flexgate. Well, Mr. No Name, you may ask away if you have questions. We're about to show a better view where you get to see what is going on, what we are doing. The problem here is called Flexgate, and it is when Apple designed this model, this cable is a little bit too short. So the bending radius of this cable is a little bit too small, and it will crack after being bent a certain amount of times. I'm going to move these screws to somewhere where I'm not going to bump them by mistake while not paying attention. Grab my kit. Push this a little bit more into view so we can see under the microscope. And now this jig, that you can see in the bottom left-hand corner, this little one, this goes here, goes around it. Like, it doesn't really want to wiggle because that internal guide as well for the screen that we made on it. Put our wedges in, and there you go. You now have your kit in place, your jig in place. It allows you to bend your wire over. I will probably manually mark these with this scratch on it right here so that you know where the cut is going to be. If it doesn't come with that, put your jig on it, score it, the cutting jig that is, so that you know exactly where it is going to be cut. And then from here, get a new razor blade because this one's filthy. I like to use number 15s. These are blade number 15. Take it and start preparing. Oh my, what is this? This is odd. This is a lot harder to remove than normal. Interesting. So, we've removed 2 layers of black. Let me zoom in to help with the auto light. And focus a little. Yes, there we go. Focus well. Now you will see that there is some copper underneath of it. You can see the left and the right side lines. That is some sort of a flexible brass. And then you can kind of see dark copper. The thing is that you still have a layer of glue on top of that. So you want to keep going. You do want to be careful and gentle. You want to make it shiny. And that's removing all the glue so that your solder can do its job. There we go. At this point, I blow it off. Get my soldering iron out. I have set my soldering iron at 550 degrees. This is an important point so you do not destroy your cable. A little flux on it. It's a lot of flux. Grab some solder. And I like to do just the feedback lines and this little medium line next to it. There we go, just like that. I'll wipe off that flux. Get my cutting jig. Grab my nice and new razor blade again. And swipe it. There we go. So, what we have now is a line that is flush cut, that is ready for our new flex to go on top of it. I'm going to zoom out for this part so you can kind of see a little, and not much more of what I'm doing here. We will get the soldering jig, hold that cable down. I guess this is one of those two-step where it's a good idea to have 10 hands. This is just a complicated print. Put the new jig in, or the new flex in where it lines up. And make sure that your cut cable goes underneath of it. Don't poke this end of it, because you can and will damage the very fine brass or copper leads sticking out of it. And this is where I like to hold it down, grab the soldering jig. This is so much more complicated when I know I'm being filmed. There we go. Line this up. Click it into place. Get my soldering jig on it. And there we go. So, you'll notice it is not perfect yet. You do a little finessing. And there we go. That is what I'd like to see. It's still good. Yep, still good. We are going to get a little flux onto it. Try to zoom in so it is not too bright and shiny. And I like to start with the sides. Grab my tweezers. I still have a habit where I like to hold everything down. There. Put a little glob of solder on it. There we go. Make sure everything is still lined up. It looks like it is misaligned a little. Don't know what happened there. There we go. Oops, it easy. Get back down there. Grab the other side. Rinse and repeat. I need more lead on my iron. There we go. Okay. And then at this point, we are going over all of our feedback lines. Pretty much it right there. Let's get this one. I do not like this much solder on the joints in general, so we're going to remove some. There we go. Make sure these are all brilliant. Now, if you remember how I showed you at the very beginning of this video, these flex cables have exposed copper in the back. And that means that they are connected below as well as here on top. And they are shaped in a way where it is thinner than paper, because these are already paper thin, to have a good connection. So that there's not a big, oh, what's the right word for it? A big height difference between the bottom of the flex and the top of this flex. So we will go ahead and remove that jig, grab some alcohol, grab our Q-tip, clean it up, dry it. And now this point is actually pretty important. Our kits also include a little piece of tape that I have misplaced. There we go. Grab that. A little piece of tape like this that's going to go on like that at the end, and it gets glued on. So I use T7000. Run a very small bead from there. This helps give it that mechanical reinforcement as well, and it is flexible. And now gets placed just like that. And you are done. So this tape is a tape that will become a little bit more sticky over time as well. It is actually, oh, what is the scientific name? I honestly don't remember the name of the type of tape off my head. It is not just electrical tape, it is a different type of tape, for anyone wondering. Let us kind of look here again. Push this underneath. Now, something that you're going to notice is different than before and the repair that we just saw is where this repair is on the cable. So let's plug this in. Now, where is the repair? The repair is down here in a place where it does not bend. So, when you are opening and closing this, that is actually a part that is sliding. Let's see here. That is a part that is sliding back and forth like this, instead of going around a bend like this. And when it's going around a bend and you put solder on it, it will crack, it will fracture. So as the two layers on top of each other, it's done down the flex towards the screen enough where it's actually a part that is just sliding back and forth. And that is why it will not fail. Unlike this other repair that we just removed, that, well, the repair was applied where it bends. And let's see if we can really zoom in here, take a look at it. Yep, that, it was cracking, indeed. Right there. So, I suppose let us plug in the battery, turn it on, and show you that it's working. I do not believe that we have a password for the system. And I was just showing you something under the microscope that you couldn't see. I'm an idiot. Let's see here. Okay, let's try this again. So, where's that flex I just tossed? And throw in the trash can. How that? Dang it. My desk is too messy. All right. Let's see. Selfie and battery. Battery screw. The idea of this jig is that you can knock these out pretty quick if you have a bunch of them, as well as in a way that you won't get them back for warranty, which I always think is a plus. Here we go. Move this out of the way, go down to the desk, open the screen up, plug it in. Note to self, show that it does not work first next time. I'm trying to think, does this have a client name on it? Oh, you know, these computers, it really helps if you actually plug in the screen too. Got so excited to show you it worked, I forgot to plug in the screen. Look at those. And there we go. Apple logo tilted up just in case it does show user information. Okay. Then what can I put on top of it? Silicone mat? Right, maybe. Oh, there's two names. Okay. There we go. So with that, open up all the way, close it all the way. Well, it's not going to do anything on you because the cable is longer and it is not going to be a problem anymore. So that's why I do not appreciate or like the repair that is just making a couple of jumpers on the cable, especially there in the flex region where the diameter of the cable is bending, and why we do it this way. We have not had a MacBook come back yet in warranty for this repair. I always do tell and talk about warranties and how a lot of shops and people say something like, oh yeah, well, we never have a device come back under warranty for this repair. And I can guarantee you that the shop that did this repair did not get this back under warranty. They just brought it to me because we have that reputation here to be able to do quality jobs, and we stand behind our work as well. Thus, yeah, they did not have this come back under warranty because they did not want to have it fixed the same way. So they brought it to us where it could be permanently fixed. And I do say I have not had one of these back under warranty yet, but I have seen those computers several times. And I've seen quite a few of them with, unfortunately, Deathgate has come up. Change of batteries because 2016, 2017, it's becoming the time to change the batteries. Logic board damage from spilled liquids, and I have seen devices that I've worked on before with the Flexgate Repair, and they're holding strong. I actually saw the first one that I repaired with this method, actually ever, because this is the only method I've ever used. And it had different tape on it. It had Kapton tape instead of this other tape. And perfect. It's absolutely fine. Nothing wrong with it. Just like I was expecting. So that's why we do it this method. That's why I kind of like preach by this method as well. I don't like taking shortcuts, or I don't like to use thicker wire. I've repaired some speakers in the past, quite a few years ago, and I put a little bit too much solder on the braided cord that goes from the coil to the cone. No, from the cone to the actual, like, coil. Yeah, okay. and putting just a little bit too much solder on that caused there to be a rigid part that went maybe 2 millimeters in out of 50 millimeters, not very much, and it broke. It broke right there because it was rigid and everything else, the rest of the cable was vibrating, and that caused a weak point, and that's where it broke. And with things that are going to move over and over and over again, like a hinge having leaded solder or leadless solder in it, where it is flexing, you can only bend solder so many times before it breaks, especially a little copper wire. Any sort of a copper wire is going to break after it's bent too many times. It's one of the properties of copper, is that it is a work hardening metal that once you bend it, it becomes harder and more brittle, and it will crack. So even if you use a thicker wire, it's going to break. If anything, a little bit quicker, because that thicker wire is going to become more brittle quicker. That's why stranded wires are a thing instead of a single core wire if you need something to be flexible, because, well, it's a lot easier to bend, as well as you're not stressing the metal as much. Just in the engineering standpoint, if you have a thick thing and you're bending it, you have to stretch a portion of that metal, and then when you try to return it to normal, you don't really compress the metal much. You stretch the other side, and then you stretch it and stretch and stretch and stretch, and then it breaks. If you have extremely thin wires that their diameter is so small that when you do make a radius, you're really not stretching the metal. It's not straining the outer walls of it because the bending radius isn't a stress on it. If you do use really thin wires, with the lead on there, it is still going to fail, especially if you're not lengthening this wire to the appropriate length. So that's why we do it. Hope you learned something. Hope you enjoy it. I'll have a link down below if you would like to purchase this kit. We actually do have it open to the public now. It's quite costly. It took quite a bit of work to build it. This is not just PLA or some plastic that you can print on a normal printer. It is heat resistance. I don't know if you guys noticed, I was kind of moving it around a little bit with my soldering iron at 550 degrees. No damages to it. The cables, we make them by hand. If you want to try to make them yourselves, go for it. I might be releasing a kit that includes a tool that we use to make those, just to make it more economic to be able to reuse one of these kits over and over and over again for you. If not, we do sell the flex cables ready to go in a box, so that when you get it, you just have your 3 cables, pop one into the MacBook, toss it off to the side, wait for your next repair, and then keep going on from there. To be able to, get these in and off of your desk as quick as possible without worrying about seeing them again. Thank you for your time. Hope you learned something, and we'll talk to you next time.